Hey guys, welcome to this video on vectors with complex numbers. So we've looked at vectors before and how they work and what we can do with them. Now we're going to look at them with complex numbers. And the reason we do this kind of stuff with complex numbers and vectors is that it does have real world applications. For example, if you're looking at becoming an electrical engineer, you actually use this kind of stuff in electronics where you're looking at three-phase circuits. So let's make a start on this. So what we've got here is a set of x and y axes as we'd normally know them, so x being the red, y being the blue. But in this case, our x-axis is what we're going to call the real axis, and our y-axis is going to be our imaginary axis. So what we can do with this is plot both real and complex numbers in the form of vectors on here. And we actually have a name for this, so we could call this a complex plane, or a more mathematical term for it is the Argand plane. So let's look at how we're going to plot some numbers on this. So let's say I have a point OP, or vector OP. So P could be a point out here. Let's call that P. And normally it would have an associated X and Y set of coordinates with it. In this case, OP is going to be X and Y, like we've seen previously. And what this represents is X plus YI. So we could find that if we have, and obviously O being our origin, we could use this to then look at all different types of vectors. For example, let's go OA being equal to 4 minus 1. Now, if I was to write this out as x plus yi, this would be 4 take I. What that means is we're going to be 4 over here on our real plane, on our real axis, and then minus 1 on our imaginary axis. So, for example, it could be down here. Let's go 4 minus 1. That's our point A, and our vector is going to be that there. And that's really how it works. So we can use all the math that we've done before, all the stuff that we've done with vectors before, in order to plot and manipulate these vectors. All the vector addition, subtraction, multiplication that we've done all comes back, and it's all going to be exactly the same. So there is nothing really new that you guys haven't seen before. It's now just dealing, instead of x and y, we're now dealing with real and imaginary. Another bit that we talk about here is the modulus, which again was spoken about, and it's just finding the length of it. And in this case, it's exactly the same, although there is a little bit to do with some of the conjugate stuff. So what I want you guys to do is to get this copied down. I'm going to clear the screen and we'll talk about the properties of modulus here, because there's a little bit to do with conjugates. So pause the video, get this written down, and then we'll continue. Alright, so hopefully you guys have got that written down. We're just going to go through quickly the properties of modulus and how it relates to what you guys have seen before. I've got here z equals a plus bi, and that is the length of the vector ab, and to work it out, it's just going to be the modulus of z, or z, which is equal to the square root of a plus b squared. Now, for anything like this, we're going to just take the number there that is in front of B or A. So let's do a quick example. Say if I have z being equal to 3 take 2i, then the modulus of this is just going to be equal to 3 squared plus minus 2 squared. I'm not worrying about the imaginary part here. I'm just worried about the magnitude of the imaginary part. If we crunch all the numbers, then we're going to end up with it being equal to the square root of 13. Obviously 3 squared is 9, minus 2 squared is 4. Add them together, you get 13. Alright, so looking at the properties of modulus here. If we've got a vector z, then the length of it, even if it's conjugate, is still going to be the same. Z, so that's the first point here. If I've got the modulus of z squared, then it's just equal to z times its conjugate. So z times z star, which again is conjugate. The last two properties, which are here and here, you guys will be familiar with from our work with vectors, where we've got z1 multiplied by z2. It's just the modulus of both of those multiplied together, and division works out the same. So hopefully you guys have been able to understand what's going on in this video. If you do have any questions, just ask. I will go through some proofs of these in class, especially this one here. So we'll go through that in class and show you how that works. So again, if you've got any questions or comments, please let me know. Otherwise, thanks for watching, and we'll see you next time.